Okay, this is PreCalc 4.2 notes. The second part of day one. We had several questions on the white worksheet that took some of our time. So we're looking at special right triangles, and we have a special right triangle song. I believe they're sung to take me out to the ball game. And I think I've been pretty honest with students in the past. My singing is much akin to cats being caught in a dryer. Um, I won't do that actually for you, but I'm sure your imagination will run wild with what that might sound like. So let's just talk about the fact that in a 30, 60, 90 triangle, the short side is half the length of our hypotenuse. So our hypotenuse is 2, short side's half the length. The side that's opposite the 60 degrees is the square root of 3. Okay, and that is just a relationship. Now, if I wanted to talk about it having a uh, radius 1 or a hypotenuse of 1, I'd just divide everything by 2, and it'd be 1 here, be half, and be the square root of 3 over 2. Okay, so that's what I can look at as I think about this. And if I'm looking at this one as a radius of 1, if I want to do a 45, 45, because this would be x, and x the square root of 2, or I'd be looking at this would be 1, and this would be 1 over the square root of 2, or if I evaluated correctly, it'd be the square root of 2 over 2, and the square root of 2 over 2. But right now we're just getting our feet wet again, and so this relationship is fine. Now, every student in trigonometry should be able to find these special ratios without a calculator, 30, 60, 90, and 45, 45, 90. So let's talk about them. Okay, so evaluating trig functions of 45 degrees, find the values of all 6 trig functions for an angle of 45 degrees. Now remember, the sine and cosecant are related because cosecant is the inverse of sine, or 1 over sine. Cosine and secant are related, and tangent and cotangent are related. So let's talk about the sine of 45. And I don't care where you are, I got this 45-degree angle. The sine is opposite over hypotenuse. Well, that's 1 the square root of 2. You know, it's 1 over the square root of 2, because it's opposite that 45-degree angle, hypotenuse. Now, I really need to write it without a radical on the bottom, so it's really the square root of 2 over 2. But writing it this way helps us find our inverse, or our 1 over, and I will do that with the cosine as well. And what I generally do is I do the sine, the cosine, and the tangent, and then I just go after the inverse, the flipping them after I'm done. So the cosine of 45 is adjacent to hypotenuse, so it's 1 over the square root of 2, but the final answer should be the square root of 2 over 2 as well. And the tangent to 45, well, that kind of makes sense because that's opposite over adjacent, and that's going to be 1. Okay. Now, keep in mind, the sine was opposite over hypotenuse. The cosecant is hypotenuse over opposite. And so I just flip it. Square root of 2 over 1, so it's a square root of 2. And for that very same reason, the reciprocal of 1 over the square root of 2 is just the square root of 2 over 1, which is the square root of 2. And then cotangent, the reciprocal of 1 was quite easy. It was 1. Now, for any right triangle, if we know 2 sides of the triangle, how can we find the third side? Well, we can use Pythagorean theorem, a squared plus b squared equals c squared, to help us do that. And we need to realize there are some little tricks about things making a triangle. Doesn't make a triangle. Now, this Pythagorean theorem we used as geometry students to talk about the idea of whether it's obtuse, acute, or right. And then, you know, if it's going to evaluate as obtuse, where a squared plus b squared is always greater than c squared, then we have to determine, gosh, is it a triangle at all? So we got to make sure that 2 smaller sides, if it's ever going to fail about being a triangle, 2 smaller sides is always larger than the third side. Now, part of our special right triangle needs is to be able to go through a 30, 60, 90. And right here I have a version of that ratio where it's 1 2 and the square root of 3, and generally you'd seen it as x, 2x, and x the square root of 3 here, where 30 is the smallest side, okay, and the square root of 3 is the next largest side, and the hypotenuse is the largest. Now keep in mind, with any triangle, inside a triangle, we can compare the relative size of sides based on the angle opposite them. The largest side, or longest side, is opposite the largest angle, and the smallest side is opposite the smallest angle, thus 30 and 1, and 60 and the square root of 3, and 90, wow, and 2. So keep those things in mind. Those are things we learned in geometry. Now we're evaluating the trig functions for 30 degrees. We're going to find the values of all 6 trig functions for the angle of a 30-degree angle. Now, just like I did before, 30, opposite for sine, opposite hypotenuse is a half. Okay, cosine of 30, adjacent hypotenuse is the square root of 3 over 2. And the tangent of 30, which is opposite over adjacent, which is 1 over the square root of 3, or the square root of 3 over 3 after I make it all nice and pretty and get rid of that square root on the bottom. Now, cosecant is 1 over sine, which is cosecant is hypotenuse over opposite, and it's 2. And the secant is the adjacent over hypotenuse, and that's 2 over the square root of 3, but I have to get rid of that square root of 3 on the bottom, so I multiply by the square root of 3 over the square root of 3, so I got 2 to the square root of 3 over 3. And the tangent again, this is the square root of 3 over 3, but notice over here, I don't have to do much work. It's just going to be the cotangent of 30 is the reciprocal of tangent of 30, so it's the square root of 3. That's all we're doing. Okay, example 2 is done. Let's move on to look at this next relationship. Now this is an equilateral triangle here. This is side length 2, side length 2. This is an angle bisector coming in here. You could look at it as an altitude. It's just kind of on its side. And that's the perpendicular bisector of the side opposite it. But there are two 30, 60, 90 triangles inside an equilateral triangle that's been cut in half by an angle bisector or perpendicular bisector. Okay, an altitude to any side of an equilateral triangle creates two congruent 30, 60, 90s. If each side of the equilateral triangle has length 2, each side has length 2, then the two 30, 60, 90 triangles have sides of length 2, 1, and the square root of 3. Okay, so they're just going over that particular property as we look at those. Now a word about radical fractions. There was a time when 5 to the square root of 11 over 11 was considered simpler than 5 over the square root of 11 because it was easier to approximate. But today they are just equivalent expressions for the same irrational number. With technology, either form leads easily to an approximation of 1.508. We leave the answers in exact form here because we want you to practice problems of this type without a calculator. Being able to do it in exact form allows us to do easier calculations later as well if we need that value. So we had another exploration here. Evaluating trig functions of 60 degrees. Now we didn't do them in the example, so we're just going after it, and I got a 30, 60, 90 triangle here. And remember, I suppose I should actually have those numbers filled in there. So let's just remind ourselves that across from the 30 I've got 1, okay, the hypotenuse would be a 2, and I've got the square root of 3 here across from the 60, okay, and that's always the case. Now when I'm looking at this, the sine of 60 is opposite over hypotenuse, square root of 3 over 2. The cosine of 60 is adjacent hypotenuse, is 1 over 2. And the tangent of 60 is the square root of 3 over 1, which is just the square root of 3. Now, cosecant, again, is adjacent, hypotenuse over opposite, which is this 1 over sine, which that's 2 to the square root of 3. And then I've got to get rid of the square root of 3, so I have that there. And that's what we're more used to seeing. Cosine of 60 is a half, so the reciprocal or of that would be 2 over 1, because secant is the hypotenuse over adjacent, and that's 2. The tangent, it's opposite over adjacent, but it's adjacent over opposite for the cotangent. So we flip it, and then we make it all nice and pretty, the square root of 3 over 3. Now, during this time, I want you to realize I'm going to have you find the 30. And we have find the values of the 6 trig functions for 60. Note, most of the preliminary work has been done in example 2. But now compare the 6 function values of 60 with the 6 function values of 30. Instead of looking back, I'm just going to put them back here again. Now, we've got this sine of 30, and the sine of 30 is a half, and I put those, what they were, the cosecant of 30 is 2, the tangent of 30 is the square root of 3 over 3. You got the cosine of 30 is the square root of 3 over 2, the secant of 30 is 2 to the square root of 3, and the cotangent of 30 is the square root of 3. But the sine of 30 and the cosine of 60 is the same. Okay, and incidentally, the sine of 60 and the cosine of 30 are the same. Okay, so let's talk about the cosine of 30 real quick. Cosine of 30 is adjacent over hypotenuse, the square root of 3 over 2. Sine of 60 is the square root of 3 over 2 as well. And so these are very, very, interesting when you look at them, but they are the same values. Cosecant of 30, remember that's the hypotenuse over adjacent, so cosecant is hypotenuse over adjacent. Excuse me, hypotenuse over opposite, which is 2 over 1, not over adjacent. That's 1 over sine. And we have the secant of 60. But now the cosecant of 60 is the same as secant of 30. Okay, and the secant of 30, remember, that is just the reciprocal of the square root of 3 over 2 from cosine, so it's 2 to the square root of 3 over 3. Now, the tangent of 30 is the same as the cotangent of 60, square root of 3 over 3, and the tangent of 60 is the same as cotangent of 30, which is the square root of 3. These are very curious, okay, because now if you look at these 30 and 60, okay, add up to 90, 30 and 60, everything, the two angles add up to 90. So if I'm looking at the tangent of 30 and the cotangent of 60, tangent and cotangent, cosecant and secant, sine and cosine. So I have, these are called co-functions. So for trig functions, a function of any angle is equal to the co-function of its complement. So I can represent those co-functions. The sine of theta is equal to the cosine of 90 minus theta. The cosecant of theta is equal to the secant of 90 minus theta. The tangent of theta is equal to the cotangent of 90 minus theta. Or I could look at it this way. The cosine of theta is equal to the sine of 90 minus theta. Secant of theta is equal to cosecant 90 minus theta. So these are co-functions in their same value. It's kind of a neat little extra to know as you're working with these things. And these are also identities that we'll be working with in Chapter 5. Now that was supposed to be the end of day 1. That was 13 more minutes. We were shy. I'm probably going to be just doing this, and we've got that done. So we just finished out the end of day 1, so you guys can have that, and then we'll fit in day 2 today during class. Hope everything's going well, and if you got questions, make sure you ask them, but make sure you're correcting your work online, not doing your work online. Make sure if there's a question that we talk about them so we can know better for future assessments. Thanks for your work, and have a super day.